Hey there guys, AlphaKoala here. Just posting this video as a response to a question I received today. Alright, so we have three forces acting on a point. And two of these forces are known. One of these forces is unknown with a magnitude of F. The question asks, to minimize the resultant force on the point, what must be the value of F? Okay, so the first thing we're going to do is simplify the equation. So we're going to name this A and this B, and they're going to be vectors. So the first thing we're going to do is work at A plus B, and we'll make that vector A plus B. And that's going to equal, it's going to equal the horizontal component of B plus the horizontal component of A, and the vertical component of B and the vertical component of A. I've defined upwards as J and acrosswards as I, because that is the standard convention. Okay, so we know this is going to equal 14 cos 30 degrees, which will give us the horizontal component of A, plus, sorry, that will be negative because it's actually going that way, plus 8, and that will be I, plus 14 sine 30 degrees J, because this doesn't have a vertical component. Okay, and if we, plug that straight into our calculator, we would get negative 4.124I plus 7J. I should mention that I'm going to be fairly loose with rounding throughout this video, so just forgive me for that. Okay, now the next thing we're going to be working out is the angle between A plus B and the horizontal. So if we drew A plus B here, it's going to be 4.1247, and we want to work out theta. Okay. And theta is just going to equal tan inverse opposite over adjacent, which is going to equal 7 over 4.12, and that's going to give us 59.5 degrees. Okay. As for the magnitude of A plus B, that is just going to equal 4.124 squared plus 7 squared, which is going to equal 8.2145. That'll all be in kilonewtons, but we can just add that in at the end. Okay, so I'm going to rub this diagram out because I've got to try and conserve as much space as possible. Okay, so the first thing we can do is acknowledge that we now have one vector going this way at 8.2145, and we have a second vector going this way, and that would be the F, because the resultant will equal F plus A plus B, which we know is F plus AB. Well, F plus, you can see what I've done. So, we know that this is acting at 59.5 degrees to the horizontal, which, 59.5, that's the y-axis. We can work out that's going to be, 30.5, and we know that this is going to be acting at 45 degrees, because, it's 45 degrees to the horizontal. So then we can equate the angle between them, and that will be 75.5. So we'll just rub out all these extra little details here. That was just kind of show you how I got it. So the angle between these two functions is going to be 75.5. Okay, now from here we kind of diverge into two different paths we can take. One is kind of a shortcut, and that is the graphical approach. Now the graphical approach says that to minimize the values of F and the resultant, then the values of F and the resultant must act at a right angle to each other. They must be perpendicular to each other. So if we put in our right angle here, just pretend they kind of line up off my board somewhere. We know that that's 75.5, we know that's a right angle, so that's going to be 14.5 degrees. And, from there we can just use, cos theta equals adjacent over hypotenuse. Pi cos theta equals adjacent, and that's going to give us our resultant. So that's a pretty big shortcut with the graphical approach. Okay, so, if we want to find F, we just use sine theta. Hopefully that all makes sense. That's all fairly concise. I'm trying to get this video up as fast as I can because I've kind of taken a long time to respond, and I feel really bad. So sorry if this is unclear at any point. Okay, so the mathematical approach, if we didn't know that rule, we could say we still have two vectors, 75.5 degree angle, and I believe I said the magnitude was 8.2145. Okay, so we kind of don't really need a lot of this information, so I can kind of free it up for some board space, and that's going to be very nice. Okay, so we know that the resultant is, if I can just look at my notes here. Oh, sorry, we know that, okay, we just kind of labeled these as A, B, and C. That's going to be the resultant. Now we know the cosine rule states that c squared, magnitude of c squared, equals the magnitude of a squared plus the magnitude of b squared minus 2 times the magnitude of A times the magnitude of B times cos little c, which is the angle opposite to c. Okay, so we have the value of c, we have the value of these two sides and the angle, so we use the cosine rule. Even though this is in the variable form f, that is in fact okay. So, kind of evaluate the cosine rule to c squared is going to equal the magnitude of a, which will let equal f squared, plus 8.2145 squared, which is going to be, if I just calculate it quickly, 8.2145 squared is going to equal 67.48 minus 2 times 8.2145 f, because A will be f, times cos 75.5 degrees. Okay, and that is going to let us know that c squared, and I'll rub this out again just to save me some board space. And I'm just going to equate that equation, that's all I'm doing, I'm not doing anything significant. You'll have this recorded on your paper at home, hopefully, so, So that will give us c squared equals f squared minus 4.25f plus 67.478. Ooh, now if you've done school fairly recently, you should probably be able to recognize something of this form. If not, that's okay. You may want to consider looking it over though. Okay, now, there's sort of two ways to do this. We can differentiate this whole expression with respect to f, and that would give us kind of the slope of the graph. And so, the value of c, right, as if we had like an x-axis here of f values, and a y-axis here of c values, as the f value changes, c's value is going to change, and eventually we got to find an optimal point here. So if we work out what the gradient function is, which would be the differentiative of this function, when that is equal to 0, this is going to be minimized. That's something from high school that you should probably know. If not, you might want to look into it. That's, really depends on whether you want to do a graphical approach or not, on how important that actually is. Okay, so if we differentiate this, we're going to get 2c, dc, df, and you can ignore that if you want to. That's kind of something from another class. That's just there kind of for prettiness. Just ignore that if you don't like it. Minus 4.25. Okay. Now, there is a rule that states that sort of, this is going to equal to 0. Like c, dc, df, when you're trying to minimize it, is all going to equal to 0. And then you get 2 times 0 is going to equal to 0, so then you can kind of just go, in that case, 4.25 over 2 will equal f. And that will give you s magnitude. So that's, that's a good way to kind of do it. But we're going to go a little bit more in depth and kind of show you how that actually makes sense. Just so you don't think I'm lying or anything. Which, I could be doing, but I'm not. So, deal with that. So, we know that then c dc df will equal f minus 2.125. Because we just taken the 2 out. Okay, so you could say that dc df is equal to, and we'll call that equation 1, f minus 2.125 over c. Therefore, if we kind of sub 2 into 1, we can find that c times f minus 2.125 over c. Now what we've done here is we've just substituted this value for dc df into that. Equals f minus 2.125. And, that's going to give us, those c's are going to cancel out, so that's going to give us f minus 2.125 equals f minus 2.125. I know you're thinking, oh, he's kind of screwed up. That kind of doesn't make sense. But, it does, so deal with that. Basically, if we kind of take this over to the other side, we're just going to get something sort of happened here. I'm not sure what. I'm not sure where I've done wrong, but I've done wrong somewhere. And that's bad. But this should probably be a negative. And I don't know why it's not a negative, but it's not, and that's bad. Okay, well, in that case, we're in fact just probably going to skip the detailed explanation. But that should have been a negative. I've just done goof somewhere in my math, I'm assuming. But, I don't really want to remake this video, so we're just going to leave it as, this is all going to kind of equal 0. And we can explain that conceptually, because we know that c is going to equal a number, right? So c is going to equal, we'll just say 7. So c squared is going to equal 49. If we differentiated 49 with respect to f, so if we kind of put 49 equals, f squared minus 4.25 plus 67.478. And we had to derive that with respect to f. We would have got a 0 here. So it kind of doesn't really matter what value c is, because we would have got a 0 there. And that's kind of like a conceptual understanding. So that's going to give us 0 equals 2f minus 4.25. F equals 2.125. Now we know what angle, well actually now that we know f, we can actually just use the sine rule to calculate r. Ooh, okay, so we know that, actually no, we can actually just plug that into our equation, can't we? Yeah, that's going to be the easiest. C squared equals, well, we'll go C. C equals the square root of 2.125 squared minus 4.25 times 1.25, sorry, got a little sidetracked there. 2.125, that's f squared, minus 4.25 times f, f is 2.125, running into my diagram a little bit, but I can curve around that, plus 67.478. I'm probably going to have to look into getting a bigger whiteboard. And if you equate that, hopefully, C will equal something around 7.8 depending on my rounding. So we'll do that. 2.125 squared minus 4.25 times 2.125 plus 67.478. The square root of that is going to be 7.9. 7.93. And that's going to be the same answer as we got for the graphical approach, if you kind of use the sine rule in the graphical approach. So, my answer is probably off by that 0.1 due to rounding, but, I'm obviously not going to be able to fit 10 digits on a board, so you just have to deal with that. And basically, that is how you do the question. So, that might be a little bit unclear, but hopefully, if you kind of rewatch it or maybe just stop at the graphical approach, you can kind of understand what's happening. The main thing to kind of look out for at an intuitive level is, if you break this down to its derivative, you will get the rate of change. So if we look at rates of change, it's like if you derive velocity, you get acceleration, which is the rate the velocity is changing. So we want the rate of that to be changing, and we want that to be 0, because that's where the minimum maximum is going to be. That's from high school. You really should know that. Another thing you have to get your head around is c squared is going to just be a number. It's going to just, be a number. It's going to be something like 49 or something like that. So if you differentiate it with respect to x, you're going to get 0. It's all going to work out to 0. That would be, 0, so 2 times 0 is 0. So once you kind of get those two things nailed, you can kind of solve the whole problem. And, okay, so I hope this answers the question you gave me, and sort of, makes it a little easy for you. Sorry for the late response. AlphaKoala out.